Alright, today we're going to go through volumes, that's sets 26 to 27. Alright, start with volume of rectangular prisms. Rectangular prisms are also known as cuboids, and they're basically anything that's rectangular but 3D. For example, your phone is a rectangular prism, or an eraser could be a rectangular prism. And we also have cubes. So, how many cubes make up this rectangular prism is what we're looking at to find out what the volume is. One cube with 1 cubic centimeter will be 1 cubic centimeter, because a cube with a side length of 1 centimeter will give us a volume of 1 times 1 times 1, the first one being the length times the width times the height, which gives us a single cubic centimeter. We apply the same principles for the rectangular prisms. So over here, we're multiplying the length by the width and the height. The width is also called breadth in some circumstances. So width and breadth are the same. Just remember that. All right. Now, the cubic units are written as cubic centimeters or cubic meters, or sometimes cubic millimeters. Okay, now let's have a look at this rectangular prism over here. The length is what? 5. The breadth or the width is 8, and the height is 3. So what we need to do is multiply 5 by 8 by 3, which gives us 120. What are the units? Cubic centimeters. Always remember that. All right, and that's easy as that. Volumes of any prisms. Let's have a look. We've done rectangular prisms. Let's have a look at triangular prisms now. To find out the triangular prisms volume, what we need to do is find the area of the front-facing face. So to find the area of a triangle, what we need to do is half base times height, and then multiply by the length, which will be this one here, times that length. And that's the volume of a triangular prism. Okay? But we can generalize it now and say the volume of any prism is the area of the front-facing face times by the height or the length. Okay, so here we find the area of the hexagon and multiply it by the length. Here we find the area of the trapezium and then pentagon and multiply by the length. That's as easy as that. Okay, so if you don't know the formulas for the area of a hexagon or a pentagon, you can search it up and find out what it is and multiply it by the length of the prism. Same thing here. You can just cross section it, find the area of this one, find the area of that one, add them together and multiply by the length here. All right, now here are some examples. They already give you the area, so what we need to do is 32 times by 9, which gives us 283 cubic centimeters. Always remember the units. All right. Here are some examples. You guys can read through it. I'm not going to go through every single one of them because we'll be doing questions right after this. All right. All you need to remember is find out the area of the front-facing face and then multiply it by the length. All right. Now, let's look at the volume of a cylinder. The volume of a cylinder is given by pi r squared times by the height. Okay, that's the volume of a cylinder. So pi r squared will be what? The front-facing face of the circle here. Imagine a cylinder like this. Okay. So you find out the area of this and then multiply it by the length. And that's how you get the area of a cylinder, volume of a cylinder. Okay, so we'll look at this example over here. What's the radius here? 10. So we do pi times 10 to the power of 2, which is 100. We do 100 pi times by the length here, which is 20. All right, 100 times pi gives us 314 times by 20. Which is 6,280 cubic centimeters. Okay, they use 3.14 2, we use 3.14. It's whichever one they ask you to use. Usually just round it to 2 decimal places. Also, now, volume also relates to what? Fluid capacity. Like the volume of your drink bottle, the volume of a pool, etc., etc. All right, so 1 cubic centimeter is 1 milliliter of water and weighs exactly 1 gram. Need to remember this. And 1,000 cubic centimeters, let's erase this, is 1 liter and weighs exactly 1 kilogram. But remember though, this is only for water. For other liquids, it's different because of densities and everything, but we don't need to go into that. Now, here we have a half of a cylinder, so what we need to do is do pi r squared times h and then divide the whole thing by half. It's as easy as that. They're asking us to find out the volume of this, so what we need to do is pi r squared times by h. We'll put that in. 14 squared times by 20. We can actually do this. 196 times by 20 times by pi, and then see what amount you get, which is 12,320 cubic centimeters. Convert that into milliliters because 1 cubic centimeter is 1 milliliter. And remember, they're talking about water. So when it's talking about water, you can always equate 1 cubic centimeter to 1 milliliter. So we get 12,320 cubic centimeters, which is 12.32 liters. That's it. If they ask you how much the weight is, you can have a look over here. They give you the weight of the water would be 12.32 kilograms, and then find the weight of the jar, which is 1.54, which should give you 13.86 kilograms. Okay, that's it. As easy as that. Let's have a look at other volumes. So what you guys need to do is write down all these formulas so that you can refer to these formulas when you're doing your questions. So have a look at a pyramid over here. The volume of a pyramid is found by length times width times height divided by 3. Okay, all you need to do is write down these formulas. That's all you got to do, because then you can just plug in what the length and the width and the height is and get the answer. Have a look at cone. We've got volume is equal to 1/3 times pi times r squared times by h. So it's just radius of the circular base times by the r is the radius of the circular base, and height is the perpendicular height of the triangle here. Okay, that's it. And the sphere. With the sphere, we do 4/3 times by pi times by r cubed. Always remember it's r cubed, not squared. And always write these formulas down and use them when we're going through the questions. These are some examples. I'm not going to go through every single one of them because we're going to go through the questions right after. But pause the video and read through the examples so that you can get an understanding of what these questions are about. And over here, for a cone, if they don't give you what the height is, but they give you the radius and the slanted height, all you need to do is put it in Pythagoras and find out what the height is. All right? And when it's half a sphere, just divide it by 2 or times it by a half. Okay, let's keep going. Composite volumes, when you have 2 or more different shapes acting together, we just find the volumes of the different shapes separately and add them up at the end. Or if there's something missing, find out the filled shapes first and then take away the missing shape from the addition of the 2 filled shapes. Okay, go through this by yourself. I'm not going to go through this because we're going to go through these type of questions in about a few minutes. Okay, pause the video, read the question and understand what they're trying to do and see if you get the same answer. All right, just don't look at the solution just yet. Pause the video, try to do the question, use the formulas that we talked about from before, and see if you get the same answer. All right, and we can start on question 1. Let's see. First, read the question. Find the volume of these prisms, and the units are in centimeters. Always remember that. Let's do the first one. 9 times 15 times 11. We know 9 times 11 is 99. 99 times 15 gives us 1,500 minus 15, which is 1,485. Always remember the units, cubic centimeters. That's our first answer. Next one. Look at this trapezoidal prism. What's the area of the front-facing side? To find out that, what we need to do is half a plus b, so 9 plus 13, times by the height. What's the height here? 8. Times by the length, which is 10. You don't need to put this in the calculator, but if you need to, you can. So what we do first is 9 plus 13, because brackets first. 9 plus 13 gives us 22. 22 times half gives us 11. 11 times 80 gives us 180. So the answer is 180 cubic centimeters. Let's do question F. What's the front-facing shape, which will be the trapezium over here? The trapezium has side lengths of 12 and 23. Let's do half 12 plus 23 times by the height, which is 15.5, times by the length, which is 12 again. All right, let's put this in the calculator. Put that in. Let's do the brackets first. That would give us 35 divided by 2 times by 15.5 times by 12. Should give you 3,255 cubic centimeters. All right, and that's it. That's the first one. Now, let's go through question 2. Let's do 2 and C. Sorry, A and C. How do we find the volume of a cylinder? Volume of a cylinder is pi r squared times by the height. What's the radius here? The radius is 9.5, so we do pi times 9.5, and they're asking us to use pi as 3.142 and units in meters. Okay, always remember what they say in the question. Times by the height, which is 12. Okay, so we do 3.142 times by 9.5 to the power of 2 times by 12. I want you guys to put this in the calculator and see what you get. I got 3,402.79 cubic meters. Okay, remember the units that they use. All right, let's do question C now, 2C. We've got a cylinder, but it's halved. So always remember we need to do half pi r squared times by h. Good. Now, what's the radius here? The radius is 15 divided by 2, which is 7.5. So we need to replace that. Pi is given as 3.142 times by 7.5 to the power of 2 times by the height, which is 22.8. That should be a decimal place. All right, now put this equation in the calculator. Half times 3.142 times 7.5 times 7.5, so which is 7.5 squared, times 22.8. We should get 2014 and 81. So 2014.81 meters cubed. Done. That's it. All right. Let's go through some of these ones. We'll do C, D, and F. C, D, and F. Okay. Now, what's the radius here? They've given us the radius as 4.5 and the units in centimeters and asking us to do it to 2 decimal places. Now, what's the volume of a sphere again? Volume of a sphere is 4/3 pi r cubed. We know that the radius is 4.5, so we can do 4/3 times 4.5 to the power of 3 times by pi. They haven't given us what pi is, so we're going to use 3.14. Okay, put this in the calculator, see what you get. I got 381.51 cubic centimeters. Always remember the units. Done. Let's have a look at the cone. What's the formula for a cone? It's 1/3 times pi r squared times h. Pi r squared times h. Now, we know 1/3 times 3.14 times by r squared. What's r squared? 13.1 to the power of 2 times by 18.5. Put this in the calculator. I got 3,322.95. Actually, no, 94. They're asking us to put it into 2 decimal places, by the way. So 94. What are the units? Cubic centimeters. Alright, let's do the last one. 3f. 4/3 times pi times by radius cubed, but we have to divide it by 2 because it's half a sphere. Alright, let's write that down. Pi radius cubed times by a half, which is the same as 2/3. You multiply pi r cubed by 2/3. Okay, what's the radius here? It's 21 divided by 2, which is 10.5. So we have 4/3 times by 3.14 times by 10.5 to the power of 3 times by a half. Put this in the calculator, see what we get. I got 2,423 and 0.30 cubic centimeters. Alright, always remember the units. What we can do is we can do the pyramid as well, because we haven't done a pyramid question. What's the volume of a pyramid? 1/3 length times width times height. Length times width times height. What do we have? We've got 9.1 as the length, 8.4 as the width, and 6 as the height divided by 3. So we can just do 9.1 times 8.4 times by 2, because 6 divided by 3 is 2. Let's put this in the calculator. So 9.1 times 8.4 times by just 2 gives us 152.88. Oops, 52.88. What are the units again? Cubic centimeters. Always remember that. Alrighty. Last 3 questions. Good. All we need to do, because these are composite shapes, so they've got 2 different shapes in this one shape. Okay, so I need to find out the volumes of the 2 different shapes separately and add them together. Alrighty. So let's find out the volume of the rectangular prism here. To find out that, what we need to do is 5.9 times 6 times 2.5. What do we get? 88.5. Now we do a triangular prism here. What would you say the area of the triangle over here is? will be 1 times 5.9 divided by 2, because it's base times height times half. Okay, half base times height. So we have 5.9 times by 1 divided by half, and then times the length, which is 6. So put this in the calculator, see what you get. I got 17.7. So we have 17.7 here. So add these numbers up. We've got 2, 1 remaining, 6, and 1 remaining. 106.20, because there's 2 decimal places and units in meters. And meters cubed. That's it. That's our answer. Alrighty. 4B. Find out the area of the rectangular prism here. We do 6.3 times 6.3 times 7. What do we get? I put that in the calculator. 277.83. 277.83. Now we need to find the missing shape here, because it's a rectangular prism with another rectangular prism missing from the middle, so we need to take that volume away. To find out that volume, we need to do 2.3 times 2.3 times 7. What do we get? I got 37.03, so we have 37.03. Find out what the answer is. Minus 277.83 minus 37.03. 3 minus 3 gives us 0. 8 minus 0 gives us 8. 7 minus 7, 0. 27 minus 3, 240 meters cubed. That's it. Last one. We have a cylinder and a half sphere. Okay, so volume of a cylinder. Let's find out the volume of the cylinder first. We'll do volume, cylinder. That's pi r squared times height. What's the radius here? 15.8 divided by 2, which gives us 7.9. So we'll take pi as 3.14. Okay, it says 2 decimal places, so we'll take 3.14. 3.14 times by the radius, which is radius squared, which is 7.9 squared, times by the height. What's the height? 21. See what you get. Put that in the calculator. 21 times 3.14 times 7.9 to the power of 2. I got 4,115 and 32. So 4,115 point. Oops. 115.32 cubic meters. Alright, volume of the half sphere. That's just okay. So we have, that's just basically 2/3 times 3.14 times by r cubed, which is 7.9 cubed. Put this in the calculator. I got 1032 and 09, so 1032.09, and you need to add this one. Oops, you need to add this one and this one. Okay, so add them up. We have 1, 4, 7, 4, 1, 5. 5,147 and 0.41 meters cubed. And that's it. That's our answer. All right. Always remember, these answers might be a little off because they might have used a different decimal for pi, but as long as the answer's almost there, you should be on the right track. All right. Good luck. Today we'll be going through volumes level 2 questions. So we've only got 5 questions here. We'll just do the right hand side for question 1 and all the questions from 2 to 5. Alright, so let's start with question 1C. This one. Okay, now we've got a hexagonal prism. With hexagonal prisms, what we need to do is to find the total area of the front facing side and then times it by the length of the height of the prism. Okay, so we know that this hexagon can be divided up into 3 things. There's a triangle here, and the rectangle in the middle. Okay, so we already know that the height or the base of the rectangle, the base of the triangle is 11.5, because if we flip this hexagon to the other side, the triangle will be facing up and 11.5 will be its base. Well, what do you think the height is? Have a look at over here. So 4 will be the height. So we put 4 as the height. Okay. Now, what's the area of a triangle? Half base times height. So what we do is half 4 times 11.5. You guys can put that in the calculator and figure it out. This should give us 46 divided by 2, which gives us 23. Okay, but we know that there are two triangles, so we just times 23 by 2 to account for the two triangles. Okay, now what else do we have? We've got a rectangle in the middle. With the rectangle, we know that the base, or like the width, is 7 and the length is 11.5. So we just do 11.5 times by 7, which gives us 80.5. Okay, now we've got the 3 different areas of the hexagon. What we need to do is add them all together. So 23 plus 23 gives us 46. 46 plus 80.5 gives us 126.5. Now that's the area of the hexagon. Okay. What do we need now? We need to find the length of the hexagonal prism, which is 7. What do we do with the length? We times the length by the area of the hexagon. So we just do 7 times 126.5. Let's put that in the calculator. Oops. 7 times 126.5. Whoa. What happened? Which gives us 885.5. So we have 885.5 cubic centimeters. Remember, the units are in centimeters, so that's our first answer. All right, now we've got something else. We've got a cone. We'll just do it on this side. We've got a cone and half a sphere. Remember what the formula for a cone is? It's pi r squared h divided by 3. Okay, now let's figure out what the height is. They haven't given us the height, they've given us the 2 other sides. So we've got the hypotenuse, which is 10.2, and we've got 5.3, which is also the radius. How do we find this side? We need to use Pythagoras theorem. So what we do is we do 10.2 squared minus 5.3 squared. What do we get? Let's put that in the calculator and tell me what you guys get. And once you get that, we need to square root it. Okay, so by square rooting it, we get 8.71 centimeters. All right, that's our height. So we just do pi times r squared, which is 5.3, times the height, 8.71. Now divide it all by 3. Let's put that in the calculator now. Pi times 5.3 squared. So let's clear this. 5 times, sorry, not 5, pi times, we can actually use pi instead of just doing 3.14 because we've got pi over here. So if you have pi in your calculator, use pi. Pi times 5.3 squared. Let's do a square. Do we have a square here? If we don't, we'll just do 5.3 again, times by, what's the height? We got the height to be 8.71. Let's enter that. Gives us 768.63, but that's just the height of the cylinder. We need to find the height of a cone, so we need to divide it by 3. So let's go back and divide everything by 3. Whoops. And that should give us 256.21. That's the volume of the cone. So we'll just go back here. Volume of the cone is equal to 256.21. Now let's find out the volume of the half a sphere. We know the volume of a sphere is 4 and 3 pi r cubed. So half a sphere will be 213 pi r cubed, because half times 4 and 3 gives us 213. Now let's find this one. What's the radius again? It's 5.3, so we just need to do 213 pi 5.3 cubed. Let's go back to the calculator. Let's do 213, clear all this, 2 divided by 3, yep, and then put a bracket around it, times by 5.3 times 5.3 times 5.3, because that's cubed, and then we times it by pi. Alright, let's see what it gives us. Gives us 311.80. Let's see if we got that. 81, because we need to round it to 2 decimal places. So we get 311.81 cubic centimeters. Now we'll add them together, the volume of the sphere and the volume of the cone. When we add them both together, we get, let's add them together. 1 plus 1 gives us 2, 2 plus 8 gives us 0. Then 1 remaining, 1 plus 8, 6, and 5. The answer is 568 and 02. Okay, 568.02 cubic centimeters. That should be the answer for C. Oh, sorry, F. Now let's go to the next one. We've got I over here. I is a bit different because it's got holes in the shape, and it also has 3 different structures that we need to look at. So if we're looking at this one over here, zoom in a little bit. If we're looking at this one over here, it's 2 times 12.2 times by, what's the width? 4. Okay, let's have a look at this one. This whole height will be 2 plus 3, which will be 5. So we'll do 5 times 12.2 times by, what's the length over here? It'll be 4.5. Okay, now we've got this structure's length. What about this one? So we know that this part is 4, this part is 4.5, so what's remaining to make 12.6 will be 4.1, okay? So we know that this structure is 4.1 times by 12.2 times by, what's remaining? We've got the height, which is 2 as well. Okay, now we've got the volumes of all these structures, 3 different structures. What we need to now figure out is the volume of the cylinders inside. To find out the volume of the cylinder, what do? We do pi r squared times by the height. What's pi here? Sorry, what's the r here? Radius. If the diameter is 2, the radius will be 1. So we just 1 squared is just still 1. So we've got 5 pi times by 2. So volume of cylinder, I'll just do times by 2. It's 10 pi basically. Alright, so we've got 10 pi for the volume of the 2 cylinders. I'll just write it again. Now, what we need to do is to find the individual volumes of these 3 structures and take away 10 pi. Let's put that in the calculator now. Let's delete all this. Okay, we have 12.2 times by 12.2 times by 8, because it's 2 times 4, plus, oops, just get rid of the extra one, 12.2 times by 8, then we have 5 times 4.5 times 12.2, plus we also have 4.1 times 2 times 12.2. Okay, let's see what we get. We get 472, and so 472.14, and then we take away 31.4 because that's 10 pi. Okay, so 31.4 should get around, that's a bit weird. Let's see if we got the question right. 440, yep, that's right. So this is the answer, 440.74. Let's go back and put 440.74 cubic centimeters. And that's it. Alrighty, now let's look at the dumbbell over here. The dumbbell pictured is made from solid metal. Alright, calculate the volume of the dumbbell correct to 4 significant figures. Remember, 4 significant figures. Now, we've got 3 cylinders here, and 2 cylinders are the same. Let's find out the first cylinder's volume. It's got a diameter of 12.2, so the radius will be 6.1, and the length will be 5. So we'll just do 6.1 times 5, sorry, 6.1 squared times 5 times pi, and times this by 2 to get the volume of both these cylinders. What do we have left now? Oops, I'll just make a line here so that we can do the working off of this one separately. Now we've got another cylinder over here. It's got a length of 20.5, okay, times it by pi, and then a radius of, sorry, a diameter of 4.3, so the radius is 4.3 divided by 2, which is 2.15. Now what we need to do is add these all together. Let's go back to the calculator. So we have, let's do the 2 cylinders first, like the very first one. On the very left hand side we have 6.1 times 6.1 times 5 times pi. Oops. Times pi plus, actually, go back, times by 2 because there are 2 cylinders, plus, now the cylinder in the middle, 20.5 times 2.15 times 2.15 because it's 2.15 squared, and then times by pi. Okay, now this gives us the volume of the dumbbell, which is 1466.69, but they're asking us to round this to 4 significant figures, so it will just be 1467. Let's go back and write 1467 not kilograms, cubic centimeters. All right. Now, they're saying if 1 cubic centimeter is 5.455 grams, what's the actual weight, actual mass of the dumbbell? Okay, so what we need to do is take 1,467 and times it by 5.455. So times 5.455 gives us, hold on, that's not right. So we'll just delete this. 1,467 times 5.455. We get 8,002.48. Let's have a look here. They're asking us to answer the nearest kg. Okay, we have 8,002.48 grams, which is roughly 8 kilograms. So that's the answer, 8 kilograms. Alrighty. Now, got another question. A cylindrical water tower is 5.1 meters high and has a diameter of 2.4. Find the volume of the tank. Corrected 3 significant figures. That's very easy. The diameter is 2.4, so the radius is 1.2. And the height is 5.1, so we just do 1.2 to the power of 2 times 5.1 times pi, and then find out what the answer is. Let's go back to the calculator. We know that 1.2 times 1.2, 1.2 to the power of 2 is 1.44, times by 5.1, which is the height, times by pi, which gives us 23.1-ish, okay? Because they're asking us to correct it 3 significant figures. So 3 significant figures would just be 23.1 cubic meters. Now remember, 1 cubic meter is what? How many liters of water? 1,000 liters of water. Okay? Then they're asking us the amount of water when the tank is 3/4 full. So we go back to the calculator and times this by 3/4. 3/4, what's 3/4 in decimals? It's just 0.75, which gives us 17.303. Okay? And we just need to times this by 1,000. If we were to times this by 1,000, we get 17,303.89, and round it up to the nearest liter, which gives us 17,304. Let's go back to this 17,304 liters. That's our answer. Okay, now let's have a look at this one. This one's a bit harder. Calculate the volume of metal in the length of pipe shown. Okay, correct to 2 decimal places, and the units are in cubic centimeters. Well, we have to answer in cubic centimeters, but the units are in millimeters in the diagram. So to find out what the surface area of the front-facing side is, we need to have a look at the triangle over here. It's an equilateral triangle. So in an equilateral triangle, you need to find out what the height is, because the height hasn't been given to us. To do that, what we need to do is we need to use Pythagoras. Okay, if we were to use Pythagoras, this one will be 34, and this will be the half of this length, which will be 17. So we'll just use Pythagoras to find out this length. Alright, so we'll go back here. We do 34 to the power of 2. So it's just basically 34 times 34 minus 17 times 17. Okay, which gives us 867. Now what we need to do is find out the square root of 867. 867. What does that give us? That gives us 29.44, and that's our height. We'll go back here and say the height is 29.44. Now that we know what the height is, what we need to do is to find out the area. What's the area of a triangle again? Half base times height, so we have 34 times 29.44 times by half, and that should give us the area. of the front-facing equilateral triangle. And to find out the area of the full prism, we need to times it by 88. Okay, let's put that in the calculator. 29.44 times by 34 times by half. Oh, whoops, why is it inside the square root? To get outside the square root, times by 34 times by half times by 88. This gives us 44,049.52. Okay, let's write that down. Let's go back here. This full thing is 44,049.52. Remember, this is in cubic millimeters. Now what we need to do is to find out the hollow length here. It's a little triangle again, and another triangular prism. To do that, what we need to do is find out the area of the front-facing triangle again. So to do that, we need to use Pythagoras, or I can show you an easier way. Let's go back here and search up equilateral triangle formula. Whoops, no, area. And this gives us a formula that's much easier. It's √3 a squared divided by 4. Okay, but for the sake of doing the actual question, we should probably go through what we did before with the Pythagoras theorem. Okay, so we have another triangle. The half of this length will be 5.5. This length, the hypotenuse, will be 11. Okay, knowing that, we know that the hypotenuse squared is 11 squared, which is 121, minus 5.5 times 5.5, which gives us 90.75. Now what we need to do is put 90.75 as a square root, which gives us 9.53. Okay, so we know that the height is now 9.53. To find out the area of the triangle, what we do is 9.53 times by 11 times by 0.5. Let's do that. Times by 11 times by 0.5. Oh, whoops, it's inside the square root again. I need to get out of the square root. Times by 11 times by 0.5 gives us 52.39. And we need to times that by 88 to get the volume of the triangular prism. So we go 88. Gives us 4,610.72. Let's write that here. The volume of this is 4,610.72 millimeters cubed. All right, now all we need to do is take this amount and minus this from it. Okay, so we have 449.52 minus 4,610.72. Let's do that. So let's get rid of all this. 44,049.52 minus 4,610.52 gives us 39,000. Oh, not 52, it's 72, which gives us 38.79. Okay, let's write that. 39,438.8 millimeters cubed, and they're asking us to put the answer in cubic centimeters. To do that, we just need to divide this by 1,000, which gives us 39.44 cubic centimeters. Alrighty, Let's go through the last one now. Find the volume of the triangular prism pyramid pictured. The dimensions of the base are shown separately. That's pretty easy. Remember, volume of a pyramid is a 1/3 area of a triangle times by the height. Okay, this is just half base times height. Alrighty, let's just plug in the values. We already know the area of the triangle is going to be 15.3 times 6.8 times a half, and we just need to plug all this into this formula. So 1/3 times by 15.3 times by 6.8 times by 0.5 or half times by the height here, which is 18.8. Now let's put all this in the calculator. Come on, delete. There we go. 15.3 times 6.8 times half times 18.8 divided by 3. What does that give us? 325.99, and that's our answer. 325.99 to 5 significant figures. What are the units again? Centimeters, so we have cubic centimeters. That's the answer. Alright, and that's it, guys. Have a look at the answers over here and finish off the questions from question 1. Alright.